All right, we've been looking at slope-intercept form, point-slope form. We're looking at these different ways we can write an equation for a linear line. Now we're going to look at if we have parallel lines or perpendicular lines. So parallel, kind of like the L's in parallel. Parallel lines are two lines that are going in the same direction. And so if we have two lines like that, that'd be parallel. Or like that, that'd be parallel. Or like that would be parallel. Two lines that never intersect. Obviously, my picture is not perfect, but parallel lines are two lines that will never intersect. So two non-vertical lines are parallel if and only if they have the same slope. Remember that slope is your rise over your run. And so if we have a line like this, and it goes rise, run, rise, run, rise, run, forever and ever 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 and ever. And then you have another line that has the exact same rise, the exact same run. You're going to have the exact same line pretty much, just shifted up or down. So rise, run, rise, et cetera, et cetera, et cetera, et cetera. And so if we have two lines that have the same slope, they're going to be parallel because they both rise the same amount and they both run the same amount over and over and over and over again, and they end up being parallel lines. It does have this little detail in here, this non-vertical part. Remember that if two lines are vertical, if you have a vertical line, the slope of that line is undefined. So you can't say that these two have the same slope. It's undefined. It just doesn't work like that. And so two non-vertical lines are parallel if they have the same slope. So let's use that information to our advantage. We know that if they have the same slope, they must be parallel. So see if you can identify which lines are parallel. I'll give you a minute. Pause it, give it a shot. Okay, so I'm assuming you paused it, you at least looked at it. Let's see, if they are parallel, they have the exact same slope. I know that if we have an equation in y equals mx plus b form, then m is the slope. So in this first one here, slope, 5/3. In this one, there's a 1 there, slope of 1. And this one we got, 5/3, hey, same slope. So the first one and the third one are parallel. So 1 and 3 are parallel. Let's go over here then. This one also has a slope of 1. Hey, there's another slope of 1. And so 2 and 4 are also parallel lines. So that's how that's done. That's how we do that. Pause it. Try these 4 on your own. Decide which ones are parallel. I'm assuming you paused it. I'm assuming you tried it on your own. I'm just going to put down which ones are parallel, and then I'll let you watch the video if you didn't get it right. 2 and 3 are parallel. This one and that one are parallel. If you didn't get that right, or if you can't see why, watch the linked video and see how that's done. Moving on, perpendicular. Perpendicular lines intersect at a 90-degree angle. And that's pretty easy to see if you have vertical lines, right? 90-degree angle, not so bad. You have an upside down T, 90-degree angle, a petit de fou. And so we've got an upside down, we've got Mr. T, upside down T is a 90-degree angle. Where it gets tricky is when those lines are not straight across or straight up and down, if they're at an angle. It's harder to find that 90-degree intersection. So that's what we're looking at. Is with these equations, what has to happen with that slope to get a 90-degree angle? So I've got this equation, y equals 2x, which in slope-intercept form, y equals 2x plus 0. So I plot the y-intercept, 0, and I know my slope is 2. So we go rise of 2, run of 1, rise of 2, run of 1, et cetera, et cetera, et cetera. And I've got my graph line. So I can graph that equation, y equals 2x, or y equals 2x plus 0. I want to find a line that's perpendicular to that and see what that equation looks like. Well, an obvious answer would be, well, I know if the red line here is positive, it's going up from left to right, and I want to have another line going negative, it's got to go down, something like that. It's got to be going down, so it's got to have a negative slope. Let's try y equals negative 2x plus 0. See what happens with that. So I'll plot my point. Rise of 2, run of 1, rise of 2, run. So it's negative 2x. Now it's going the right way, but that is definitely not a 90-degree angle. And so it's not just negative 2x. And if you plotted those points and drew the line, I apologize because I'm going to make you erase it. That wasn't right. So negative 2x plus 0, not quite right. What ends up having to happen is that we have to take this number, 2, the slope of 2, 2 over 1 I'm going to put, slope of 2 over 1, and we take the reciprocal. We flip it over. So we get 1/2 and negative. We end up having to take the opposite and the reciprocal of that number. And let's see what happens now. So I've got my y-intercept, 0 again, and I have a run of negative 1, a rise of negative 1 and a run of 2. Rise of negative 1, run of 2. And so if I connect those dots, that is a 90-degree angle. And so we can use that idea, we can use that opposite and reciprocal to get our perpendicular slope. So if you want to write that down, go for it. Opposite and reciprocal. Pardon my handwriting. There we go. Okay, so we're going to identify which lines are perpendicular. I'll start this one. So if we're going to do the perpendicular slope, we want to look at the slopes. I'm going to start with maybe the third and the fourth problems here. So if we look at these two, let's look at the slopes. The slope is 3, and this slope is negative 1/3. So 3, that's the same as 3 over 1. Negative 1/3, if I take the opposite and the reciprocal of 3 over 1, I'd get negative 1/3. So the third and the fourth graph, in this case, are perpendicular. Because 3 and negative 1/3 are opposite, one's positive, one's negative, and they're reciprocals of each other. They're the inverse, the inverted fraction, 3 over 1 and 1 over 3. Now let's go back to those first two. Y equals 3 and x equals negative 2. Those do not look typical. So let's maybe graph that to get a picture idea of what's going on. Y equals 3. So when x is 1, y equals 3. 1, 2, 3. There we go. So y equals 3. When x is 2, well, it doesn't really matter. There's no x in the problem. So y equals 3. Okay, so when x is 3, y equals 3. When x is 50 billion, y equals 3. Y always equals 3, because that's what it says right there. I'm just reading it. It says y equals 3. So it doesn't matter what x is. Y just equals 3. And we get a graphed line that looks like that. Remember, you could rewrite this as y equals, there are no x's, 0x plus 3, which would give us a slope of 0. Do the same thing with x equals negative 2. So when x is negative 2, x is negative 2. When y is 1, x is negative 2. When y is 2, x is negative 2. When y, you get the idea. Negative 2, always, always, always negative 2. It doesn't matter what y is. X is always negative 2. And that gives us an undefined slope. So we could not actually write this in slope-intercept form. But it's an undefined slope. It's not a function. However, they are perpendicular. An undefined slope and a slope of 0 are perpendicular to each other. And so if you see an equation that says x equals negative 2, that's undefined. That's not a function. And it doesn't work as a function. But it is a line. And we can plot the points for the line. We can draw the line. X equals negative 2 is a vertical, undefined slope. And it is perpendicular to y equals 3. And so we would say that 1 and 2 are also perpendicular in this case. Try these four on your own. Pause it. See what you get. I'm assuming you paused it. I'm assuming you tried it on your own. The answers for this one are that 1 and 3 are perpendicular, and 2 and 4 are perpendicular. If you didn't get those answers, make sure you watch the linked video and see how that's done.